Today I'm going to talk about the IPCC report. As was already announced, I'm one of the authors of the IPCC report. And in my presentation, I will indicate how we as IPCC authors came to our conclusions, and I will share with you the reasoning. And specifically, I would like to talk a bit about whether we can still reach the Paris Agreement. Can we reduce emissions still low enough? And maybe to some degree the title, How low can we go, has also something to do with the fact that we haven't responded yet. And I would like to say something about that. So the first start is with the Paris Agreement. And so, as some of you might remember, in 2015 we have promised as countries worldwide that we wanted to try to prevent climate change by staying well below 2 degrees and preferably try to stay below 1.5 degrees. And now the question is, what is needed to meet these goals, and can we still do that? But maybe as a start, I would like to remind you a bit about what is climate change. And so the big thing is that the sun is radiating the Earth, and as a result, it's a bit warmer here at Earth. But if that was the whole story, then it would be minus 15 degrees on average on Earth. And luckily, that is not the whole story, because some of the warmth that is going back into the radiate from the Earth hits all kinds of greenhouse gases in the atmosphere, and these start to radiate that warmth, that energy back in all directions, and so partly also back to the Earth. And as a result, this works as a kind of a blanket. It's the natural greenhouse effect. And this is already discovered in the 19th century. There's nothing strange about this. This is simply well known. But also, already in the 19th century, Arrhenius was thinking, okay, if this works like this, and CO2 is one of the greenhouse gases in the atmosphere, what happens if we start to put more CO2 in the atmosphere by burning fossil fuels? Wouldn't that mean automatically that it gets warmer? And so, by the end of the 19th century, he published this famous article where he said there's also this anthropogenic enhanced greenhouse gas effect. And after that, the story becomes a little bit more difficult because, okay, that means more energy, but where is that energy going? And that took us a long time to exactly find out, but by now we know that this is going to increase the temperature on Earth. And that is quite serious. Because we know that the CO2 in the atmosphere has increased quite a bit. On the left, you see the CO2 concentration in the atmosphere over the last 800,000 years. It goes up and it goes down a bit. But as a result of burning of fossil fuels, we have now increased the CO2 concentrations to quite a lot above the natural level. And we can see the consequences as well. We see that the Earth is warming. And over the last about 150 years, the Earth has warmed by about 1.2 degrees Celsius. This is simply also not indisputable. We can simply measure this. And as a result, we see also all kinds of climate impacts. I just had to get some headlines of this year, but climate change linked to Pakistan floods, study finds this summer. Limburg flooding last year caused by climate change, researchers find. Climate change made India heat wave 100 times more likely. And so we are experiencing currently climate change, and the world is rapidly becoming affected by climate change. So what is the cause of this? This is the CO2 that we are adding to the atmosphere and the different sectors that are emitting CO2. So partly it is related to energy production, directly the CO2 emissions from mining and from refineries. A big share is coming from electricity production. We have buildings, industry, transport, agriculture as well, land use change. And we can add to that actually also the fact that there are two other greenhouse gases, which are methane and nitrous oxide. And then the picture becomes quite clear. The emissions are associated with many things that we do as humans. It's associated with the way we live, the buildings, our buildings. It's related to the goods we consume and that we are produced by industry. It's directly related to the way that we travel. and it's also related to our food. To basically everything that we do is at the moment creating greenhouse gas emissions. And so getting rid of this stuff means changing more or less everything. So if we try to understand how this works, we have to understand this whole chain of events coming from human activities to energy, to emissions, to greenhouse gas, to climate change, and to impacts. So we have to follow that whole causal chain. But not only that, we have to see how this develops into the future. We have to see how this relations work in time. If I build a coal power station now, that power station is going to be there maybe for 40 years or so. And so somehow I have to take that into account. I have to account for geographical relationships. And so if I, in Europe, make a policy on bioenergy, and that bioenergy is produced somewhere, it might mean that there's in South America bioenergy produced, which could lead to deforestation. And so also geographically I have to understand everything. So that means that at some point in time it becomes a little bit too difficult to do everything with your head. And that's why in climate science we basically use quite a lot of models. And that we're not doing that because we feel that we can predict the future. The next US elections or a war somewhere makes the future completely different. But we can use these models to explore pathways and to understand a little bit the dynamics of how things work. And basically we have three different areas where scientists are using models to try and understand how possibly the future could evolve with respect to climate change. There is one set of scientists that are looking into how will human activities evolve into the future, what kind of technology choices do we have, and how does it affect emissions. There's a second group, which are meteorologists, which are looking into if there are emissions, how does it lead to climate change. And so they build these very large physical models. And finally, there's a whole group of people, mostly ecologists and geographers, that try to understand, okay, if the world gets warmer, what are the consequences of that? And are those acceptable or are those threatening? And so we have these three areas of research. My own research is mostly on the left side. And so that's what I'm trying to do, trying to make scenarios of future human activities and how that leads to greenhouse gas emissions. So now focusing a little bit on what comes out of that. This is the development of greenhouse gas emissions on the left. So that is CO2, nitrous oxide and methane combined. And CO2 in the middle. Now CO2 is by far the most important greenhouse gas. First of all because it's in volume, very large. But secondly also because it's very long-lived. So if we put CO2 into the atmosphere, part of it will stay there for centuries. And so that's why we also focus mostly on CO2. So this is the historical projection. So we can see that since 1970, but also before, greenhouse gas emissions have been constantly rising. There are some dips with crisis. The latest one is the COVID dip. You can see that last blip in the end. But by now, in 2021, we are simply, unfortunately, back to the emission level of 2019. So the next thing that we do is try to develop scenarios of how things might evolve. And so we're telling stories with computer models about what would happen if people would continue to rely heavily on fossil fuels and economic growth would be relatively fast. Or what would happen if there would be some kind of a shift. And maybe population growth is fast or slow. And so we make all kinds of projections, and that's indicated here. These are projections in the absence of climate policy. So these are basically projections that we make where we describe the world as we saw it in the last decades. But still, there's obviously a huge amount of uncertainty. In the IPCC report, we also added a second set of projections, which are basically the best estimate of what would happen if countries would actually implement climate policies. And so we made a database of the 6,000 climate policies that we could find in different countries, and we made our best estimate of what those would mean. And that resulted in the red line, and also the uncertainty range that is around it. We asked different modeling groups to estimate what the effect is. That's why we have an uncertainty range. But basically it means that if countries start to implement the current climate policies, emissions would more or less stabilize. That's already a little bit less than the projections that we originally had for what would happen if you simply continue as we were doing historically. But I will show that this is clearly absolutely not enough to reach Paris or to really prevent dangerous climate change. But so the basic story is current policies, more or less stable emissions. So if we now would like to understand what that would mean for climate, we can run these large climate models of the meteorologists, but I can also do a little trick. And the little trick is I simply look into the IPCC report and I look up all the projections that have been made by these models, and I plot the cumulative CO2 emissions, so that's the CO2 emissions that is put into the atmosphere, against the temperature output that these models produce. And actually you can see that all these models are in agreement pretty much. And so there are models that are a little bit more sensitive, so they would be on the upper side of that pink plume. There are also models that are a little bit less sensitive. They would be on the lower side, but we basically more or less have a strong agreement among the climate scientists of how this system works. And in principle, the more CO2 you put in the atmosphere, the warmer the Earth gets. Now that graph is very handy to have, because what we can now do is simply calculate the integral under that CO2 emission curve in the middle, and then we know how much CO2 is emitted, and then put it into that graph. We can't start at zero, unfortunately. We have to start at the point of 2,200 gigatons of CO2 that we have already emitted into the atmosphere in the last 150 years. So we have to add to that. But then we can take this 40 gigatons of CO2 from being stable, multiplied by 80 years, and then we can calculate how much climate change that will cause. Yeah, and so unfortunately it doesn't come out nicely on the projector, but what you should have seen here was this line at current emissions going up, and then you would have seen that for this middle scenario, you would end up somewhere between 2.2 to 3.5 degrees of warming, depending on whether you believe the least sensitive model or the most sensitive model. And you can see actually that number directly in the IPCC report. The IPCC report has this number in there. So we could have done it here on a single slide. But also, you could also have looked in that scenario, but it's also still possible, where we don't have policies, and then you would end up at about 4 degrees. So is this bad? Now, I already indicated that there is a third group of scientists which are looking into the impacts of climate change. And their work is summarized in that graph. And what they have done there is look into 5 different classes of climate risks. On the left, you have the risks for sensitive systems. Think of, for instance, of coral reefs. We know that coral reefs are impacted by climate change. We also know that with 1 degree, they're already suffering. We know that with 2 degrees of global warming, they're probably gone. And so that's indicated in that graph as well. So being dark red means very high risk. Being white means low risk. And so for these sensitive systems, you can see that it moves from yellow to dark red at around 2 degrees. Another form of impact are weather extremes, so heavy rain or flooding. And again, they have tried to map that in terms of temperature. And you can see again that for 1 degree it's yellow, for 2 degrees it's dark red. The third and fourth column are actually connected. And there they have tried to indicate events like reduction of crop yields. And so those crop yields reductions, negative impacts on crops, can be local, only in Africa, for instance, or they can be such a scale that it has an effect on the global crop yields. And so the third column is indicating local effects. Fourth column is indicating that this effect is so large that you would have a global impact. And again, they have mapped at what temperatures they believe these kinds of impacts would be really, really important. Again, it's 2 degrees would be for local impacts and slightly higher for large-scale global impacts. And then we also have the risk of large-scale discontinuities. So that would be, for instance, impacts on the Gulf Stream, which could be heavily slowed down. We believe that this is even possible already at 2 degrees. So yellow, very high risk, also very high consequences, and the likelihood increases also if the temperature continues to warm. Now that 2.5 to 2.2 to 3.5 degrees warming is in the red zone for everything. And so current policies are still bringing us heavily into the red zone. That 4 degrees warming that I was talking about as well, if you don't have climate policies, that's absolutely in the dark red. So that's things that we don't want. And to make it even more relevant for the Netherlands, sea level rise. So this is sea level rise. The point there is 2100. And then you have the blue graph indicating about 2 degrees warming, and the red graph indicating 4 degrees warming by the end of the century. The main point is that sea level rise will simply continue and continue if we have temperatures above 2 degrees by the end of the century. And so maybe that 1 meter of sea level rise for the 4 degree scenario is something that still is doable in the Netherlands by increasing dikes. But at some point, that 3 degrees or 4 degrees or 4 meters, 5 meters, 6 meters, that is indicated for that red scenario. At some point, that becomes simply for the Netherlands impossible to defend itself against. And so for the Netherlands, it's clearly very important that we try to avoid being somewhere above that blue line. And so very locally, we have a very clear interest. And policymakers already saw that. And policymakers already in Paris agreed, okay, we don't want that. Let's try to stay well below 2 and preferably 1.5 degrees. Now we have, luckily, it doesn't mean no climate change. You're still, even for this unique and threatened systems, you're still in the red area, even without something like that. So you will have climate impacts. We will have to adapt to climate change, but we think that this is still something that is doable and would give us a manageable amount of climate change. So now we can use exactly that same graph that I had before to determine how much CO2 can we then still emit if we want to meet those goals. And so if you then read that graph at 1.5 or well below, and then we have to first make a choice. Are we going to believe the most sensitive model, or are we going to take a risk and read it out at the least sensitive model? Now that last might be a bit harsh. We have one Earth and then believe the least sensitive model. That doesn't feel very right. And so what we have done is actually say, okay, let's make sure that we are right in at least 2/3 of the models. And so we read it out at this 33rd percentile. But that is still dubious, because you're still somehow a little bit gambling with the planet. But okay, this is what we have done. And so we get for 1.5 degrees, we get then a 400 gigatons of CO2 carbon budget. And for well below 2, if we take that at the 66th percentile, we get 1,000 gigatons of CO2 carbon budget. And now I'm going to put those numbers into perspective, because it is really not a lot. And I'm going to compare these numbers to that graph. And what it's showing here is 400 gigatons of CO2. Because the current emissions are 40 gigatons of CO2. And so it's 400 gigatons of CO2 is about 10 years current emissions. So if we would continue in that stable line, within 10 years, we simply have reached the 1.5 degree. So if we act as we're currently doing, by 2030, we would be at that 1.5 degrees. Alternatively, if you go down linearly, it means that you have 20 years. So by 2040, in principle, you would have to be at zero emissions. That is really fast, because most of the power plants we build are meant to last at least 40 years. So basically it means we have to build from now on everything carbon-free. And even then, we have to prematurely get rid of some of the existing fossil fuel infrastructure. So this is a tough call. Could we have done much better? Yeah, we could. This is also 400 gigatons of CO2. If we had acted after the third IPCC report, I believe it was published around that time, and simply had already believed the science at that time, this is the pathway that we could have followed, and simply a very smooth pathway down. So we put ourselves as humanity in a very dire situation. By simply not acting, we made the problem way worse than it already was. So that is also a wake-up call for if we continue on that pathway, we simply are going to make that slope steeper and steeper and steeper. Yeah, so there is a little bit of additional hope, which could help us a little bit, which is that there is also a way to get CO2 out of the atmosphere. First of all, by planting forest. And so therefore this helps a bit. There are other possibilities. There are technologies where you take CO2 from the atmosphere and would store underground. You could also, for instance, have bioenergy and then combine it with CO2 capture and put it underground. And so there are different ways where we can get some CO2 out of the atmosphere. But that is really not unlimited. And so there is a limited amount of land where we can put forest. There is a limited amount of land, if any, where we can grow bioenergy. And also the amount of CO2 that we can store underground is not unlimited. Moreover, if we really go well past that 1.5 degree and then believe that we can come back by all kinds of negative emissions, that means that we have at least temporarily overshoot the target and will have those impacts that are associated with higher temperatures. So you don't really want to go that way too much. But it gives a little bit of additional freedom. And so if you run the models of IPCC and you ask them, give me a scenario that leads me to 1.5 or give me a scenario that leads to well below 2, this is the answer that these models give. So they have now combined all kinds of technologies and behavioral changes, and as a result, resulted in these two pathways. Again, the colors don't really come out nicely, but what you would have seen was two funnels, and one is associated with 1.5, the lowest one, and then the slightly higher one that's normally purple is going to well below 2. So they reach net zero CO2 at a certain point of time. And so the 1.5 degree scenarios reach net zero at around 2050. But what they also do is they reduce emissions already by more than 40% in 2030 globally, and they start peaking emissions before 2025, more or less immediately. The well below 2 degree scenarios, they give a little bit more room, and then maybe at 2070 we can be at net zero. But that is only true if we start to reduce emissions today. Otherwise, we can get the same story as that graph that I showed you earlier. If you wait too long, you are eating up the cake very, very fast, and then at the end, there's only a small bit of cake left. So, in both cases, act very fast now. Emissions reductions in 2030 somewhere between 25% globally and 40%, and then reaching net zero by the middle of the century. So the question is, how do we get there? And we can use these models as well to get an idea of that. And so the models will try to find a combination of efficiency improvement, trying to reduce demand for energy, demand also for biomass, food and timber, which can be done by technology, partly, by insulation, for instance, and by lifestyle change. Then, obviously, we can also try to make energy more carbon neutral. We can produce energy in ways that doesn't create CO2 emissions. Renewables are a way to do that. And there at least there is some positive news. I have plotted the cost of solar panels and wind power on that graph, and they decreased rapidly. And so by AR5, that was the last report that before the current one that was published in 2014. We as IPCC still wrote, renewables are very attractive. They can provide electricity at no emissions, but they are a little bit more expensive than fossil fuels. By now we have to write simply that they are often cheaper than fossil fuels. And so that made a huge difference, the cost reductions that happened there. That doesn't mean that we can replace everything by renewables. At some point, these forms of electricity are intermittent, so you have to find some solutions there as well. And then there's also this role for CO2 removal. And we have to decide as a society how much we want to rely on it, but it probably should be part of the picture simply because we are now so close to that 1.5 degree target that there is almost no other way to also have some role there. So there is lots of different scenarios published by these models, and they show that there are different pathways. A little bit more relying on CO2 renewables, more relying on lifestyle change, more relying on renewables. But maybe now I would like to step a few steps behind and look simply at a distance to those scenarios and see whether they more or less tell a similar story. And they do. We know that a response strategy to climate change always consists of the following elements. So first of all, there's a major role for limiting demand. If we don't do that, we simply can't really cope with all kinds of supply side changes with renewables. At some point, simply demand needs to not to grow as fast as under baseline projections. And this can be done by, as I said before, a combination of technologies, efficient technologies, and possibly lifestyle changes. And then renewable energy plays a major role, simply to benefit from the fact of all those cost reductions. And so our main first target should be to make sure that electricity supply becomes neutral. And that is partly based on renewables, partly based on other things. I'll come back to that. But if we are able to get electricity supply neutral, it also means that we can try to benefit from that by, in all other sectors, trying to make things electrified. Because you benefit from the fact that you would be producing electricity at net zero. So going from fossil fuel cars to electric cars is very attractive. In all kinds of industries, trying to move to ways of using electricity makes simply the whole story easier. Now, as I said, renewables would not be the only solution. It doesn't always. There's not always wind. There's not always sun, and so you have to have some other backups in that system, which means could be batteries. At the moment, that is still not possible. So we have to think of other ways also of system integration. Maybe carbon capture and storage plays a role. Maybe bioenergy could play a role as well as a more reliable energy source. Nuclear power in some countries might be attractive to choose up to what governments would like to do. But you need to have something in that system as well, which would provide reliability. And then in end use, electricity can play a role, but not for everything. So currently for heavy trucking, for shipping, for air traffic, maybe also for very high heat applications in industry, we don't know how to do that with electricity. And so there are other options. Maybe hydrogen, maybe carbon capture and storage, maybe bioenergy again. Yeah, thank you. Thank you very much. I will wait a moment still. Yeah, so reforestation is in any case also part of the story. I've already indicated that negative emissions need to be there. Reforestation is one of the most attractive ways to get that because it can potentially be combined as well with other targets like biodiversity protection. But at the same time, there might be more necessary in terms of that negative emissions. I'm not saying necessarily that we have to use these technologies, but at this point of time I would say develop them at the very least. Actually, that is an attractive strategy to go into. And non-CO2 emissions need to be reduced heavily. I didn't focus a lot on it in this presentation, but we have to reduce the methane emissions associated with energy production. Now there we have the nice thing that if we phase out fossil fuels, we also phase out the methane emissions related to oil and gas. But there's also a lot of methane and N2O coming from livestock and from rice production. And there actually we have technologies to reduce these emissions by about a third. But there is not more technology than to offer there. We can't reduce further than about a third. Which does mean that among the lifestyle change options, diet change might be one of the most attractive ones. And simply because we don't know how to reduce these methane emissions and N2O emissions further. And the story here is actually that just going back to a healthy diet, so simply taking the health recommendations on meat consumption and accepting that would already reduce meat consumption by quite a lot. And so maybe our ambition just to go back to meat consumption levels that are healthy for our body would help also a lot for the health of the planet. So if you look at this, we have these 5 major system integrations, system transitions. We have to start producing our goods in a different way. We have to travel in a different way. We have to make sure that our buildings are going to net zero. The energy production system, the electricity needs to be different, and we have to think about the food. And these are not only technology changes. While in my presentation I focused quite a bit on the role of technologies, these transitions are much broader. We have to change the rules in how these systems are governed. We have to provide the infrastructure. And that's a story of where both government and consumers can have a role. It's not only speaking to consumers clearly, because I can't take a public transport option if the infrastructure doesn't allow me. And also in changes in how industry works is not something that I can do, but I can make some choices as well. And so clearly there are these 2 responsibilities, and somehow we don't have only to change the technology choices in these systems, but we simply have to also make sure that these systems, the governance in these systems works in a way that makes these transitions possible. And then this decade is crucial. I already indicated if we just would stay stable, then 1.5 degrees is by 2030 completely out of the window. And so we have hesitated a long time, but the emissions simply need to go down now if we want to have any chance of meeting 1.5, but also well below 2. So what has been the progress so far? And then I come back to the same scenarios that I've looked at so far. And so these is again the no new policy scenarios, the 2 degree scenario, the 1.8 is the well below 2, and the 1.5 degree scenario. And so I blow them up a little bit. In principle, yes. And so I'm now only focusing on the period up till 2030. And then I'm comparing the scenario without new policies, the current policy case, the 1.5 degree case, and the case of staying below 2. And so compared to that no new policy case, it's a 60% reduction for 1.5, it's a 40% reduction for well below 2. In the Paris Agreement, it's a bit of an odd agreement. We have made a promise for all countries together to stay well below 2. And then it says countries should do what they want to do voluntarily to achieve this. And these voluntary promises are the NDCs, the national determined contributions. Now, countries at least took it to some degree serious, so they have made promises. And if you add up all those promises, then you get up at the moment to the 70% emission reduction. And then if we use that database of the 6,000 policies and see what they are really doing, then they are implementing at the moment about 9% emission reduction. So they didn't promise enough, and they're not doing what they promised yet. There was some expectation that this would happen. So in the Paris Agreement in 2015, they built in this stocktake, this global stocktake, which is actually happening in 2023, where there is a discussion and where countries should look into their eyes seriously and see whether they believe that they are doing the right thing. Yeah, the bad news is actually that the original plan was that they, in Glasgow, would already realize this and would have strengthened their commitments. That didn't happen so much for that 2030 thing. What they did do, and that is helpful to some degree, is that they at least made promises now for 2050 to go to net zero, and some countries to 2070. So there is, at least in promises, some progress, but it's clearly not enough. It's not nowhere near the things that we have to implement. And so the pressure should be really on these governments to, in 2023, take that stocktake much more serious. Because actually the next stocktake is in 2028. So that's clear that is way too late to make the change. So the change should happen in the next few years. Am I completely desperate? I see negative things, I see also at least some positive things, and I would like to share that. The budget is clearly almost depleted, and we have this ambition gap and implementation gap. At the same time, there are some positive things. We have seen these technology breakthroughs. It is remarkable that renewables are now almost the same cost as fossil fuels, but also for electric cars. In 2014, the IPCC report said transport is maybe one of the more difficult sectors, and maybe we have to go to biofuels. By now, 2035, the EU has decided to really get rid of new fossil fuel cars. And so electric cars all of a sudden provided an option there. It's not the ideal option, and you obviously have to combine it also with public transport and other forms of mobility, but at least there is some help here. We have the net zero targets. Not enough, too late, but at least they are there. And that means that even countries like China have taken up some responsibility now, at least in terms of what they have promised. The IEA, this is the International Energy Agency, that was originally established to secure the fossil fuel demands from the OECD countries, to make sure that we had some power against the OPEC. That organization is now predicting the end of fossil fuels. And so there's also some changes happening there. And also the financial sectors, you see that, for example, the Dutch National Bank is warning against fossil fuel assets. So change is also happening there. So I deliberately didn't make the balance completely horizontal or being positive, but there is also some room of change, and you see it happening at the moment. So I've so far focused on the global scale. Unfortunately, one of the difficult things why we got ourselves into this trouble is obviously the different interests of countries. Here we see the emission developments of the world, USA, Europe, and China. And if you look at CO2 emissions per capita, you see that the USA is about 3 times the global average. EU is a bit above the global average. China is also above the global average. And then we have obviously a lot of countries that are below the global average still. If you look at the contribution of today of the OECD and the Russian Federation, just to count rich countries, that's about 1/3 of global emissions. So it's clear we can't solve the problem without also speaking about the other 2/3, which are coming from developing countries. But historically, 2/3 of the emissions came from from the OECD countries plus Russia. And so we get this big discussion with us asking them to help, and they indicating, yeah, but how did we get in this place in the first place? And can you at least solve your act first? And this gives pretty much the deadlock that we had for a long time in the negotiations. It has changed a bit with the net zero targets from India and China now. But yeah, this is still making it really, really difficult. And so climate justice is absolutely something that needs to be on the agenda to have any chance of solving this problem. And we have to take simply our responsibility. Yeah, and so if we would calculate when regions need to be at net zero based on simply the cost, which is often done in these models, and then I already indicated that 2050 more or less globally at net zero, and then you see that all kinds of countries like the US would also need to be at around that period at net zero, according to the scenarios. But that is maybe not fair. And so accepting that we had another responsibility might mean that we have to go to net zero earlier. And then copying in the Netherlands the same target that globally we have to be at net zero 2050, it might not be the way to go. Now we did take a full greenhouse gas target, not the CO2 target as the Netherlands, but clearly we have to move faster in the West than that global average to do any justice to the fact that we have a higher capability and historical responsibility. Yeah, and so maybe you want to be at net zero at 2040 and not in 2050. So for me, this is the summary. A rapid transformation is absolutely urgently needed now, simply due to the fact that we have waited so very long and all the risks that are at stake. I showed some of those on that graph on the impact, but it's clearly worth it. You can actually calculate also cost optimally whether it's worth it, and then you actually also will find out that even economically it's a logical thing to do and to reduce emissions as deep as we can. Paris would mean net zero around the middle of the century, according to the IPCC report, and I've showed you how you could easily derive that conclusion, and which countries somehow need to be going earlier. There are still ways to get there. We simply can achieve those targets by a combination of lifestyle change and technology change, and this decade will be crucial. There's also a long-term vision simply needed for those 5 crucial transitions. In the Netherlands, we had mostly made a Klimaatakkoord for 2030. I think it's really important that we make sure that is much more detailed for 2050 as well, so that we know where we really would like to be going and have an attractive idea of how that transition could look like. Yeah, so that's what I wanted to share with you today. And so I wanted to show what is in the IPCC report, and simply with a lot of graphs also show how you can derive the conclusions. So thanks.